Hello, gentlemen. Welcome back. This is the last section in Chapter 2 and the last section that we need to cover for the week. I'm actually going to break this up into two different videos. One is going to be on polynomial inequalities, which we're going to cover in this video, and the other one is on rational inequalities. So let's get started. We're going to sort of incorporate things that we've used already in this chapter to help us solve these inequalities. The first thing we want to do when we're solving an inequality involving a polynomial is to find the critical numbers. And basically the critical numbers are going to be the zeros of the polynomial. So first thing I want to do, I want to find what those zeros are. Okay? Those are going to be my critical numbers. And then what I'm going to do is I'm going to set up test intervals. Okay? I'm going to use my test intervals to determine when the inequality is true and when the inequality is going to be false. All right? I'm going to do that by choosing one representative x value in each test interval. And we can pick any value in a test interval. For example, if I had a test interval from negative infinity to 2, it would make sense to choose x is equal to 0. Choose a value that makes life easy for you. Okay, don't choose something that's going to be difficult. Okay. Once I find that value, if it's positive, it's negative, it makes the inequality true, it's going to be true on that entire interval. And so I only need to test one point in the interval to know what's going to happen on the entire interval. Sounds confusing, but it's actually not too bad. Let's look at an example. Okay, I want to solve this inequality. Here's my polynomial. I want to find out when x minus 3 squared is greater than 1. All right, and the thing I want to do first is I want to get that to be greater than 0. Okay, I want to get the 0 on this side. And I'm going to note that on this side, although you may not recognize it, this is actually the difference of two squares. And I can factor that. Okay, I can say that as x minus 3 minus 1 and x minus 3 plus 1. Okay, hopefully you guys see that. Now, once I get to this statement, this inequality is identical to this inequality. Okay, so this one's a lot easier to use. And this one we're going to easily get our critical numbers. So look at the polynomial over here, x minus 4 and x minus 2. If I start thinking about the critical numbers, it's when this is equal to 0. Well, that's easy to see that it's going to be either x equals 4 or x equals 2. I'm going to use these critical values to set up my test intervals. Okay, so I want to be in these intervals here. Get rid of that. And so what I need to do now is I need to test the value in each one of these intervals. So if I'm looking over here, I'm going to pick 0. 0 is easy. If I look at x is equal to 0, and I will note that x minus 4 times x minus 2 is greater than 0, because I get, over here, I'll get negative 4 times negative 2. That's equal to 8, which is greater than 0. So that's going to hold. This is true. We're true in this interval over here. Okay? Let's choose 3 in here. If I choose 3 and I look at x minus 4 and x minus 2, I get negative 1 times 1, which is equal to negative 1, which is less than 0. So in that particular situation, it's not going to be true. Okay? And let's look at the last one. Let me get that out of the way. Let's look at the last one. If I'm greater than 4, again, I can pick anything. Let's just choose the number 5. If I choose the number 5 out here, I'm going to get, I'll get 1 times 3, and that's going to be greater than 0. And so that's going to be true as well. Okay? Now, we have to look at these boundary points, and note that this is just greater than. If I plug in 2, this is actually equal to 0. Okay? It's not greater than 0. So we don't want to include 2 in our solution. Similarly, we don't want to include 4 in our solution. So we note that by using an open bracket here. Okay? So any value between negative infinity and 2 is going to work, and any value from 4 to infinity is going to work. And note, these open brackets mean that we do not include 4 and 2. If I wanted to include the 4 and the 2, I would have to use a closed bracket like that. Okay? All right, and we didn't do that here. So the open brackets mean they were not included. Let's look at another example. Solve this inequality. We want to check when we're less than or equal to 0. So the first thing we want to do is find the zeros. We want to find those critical numbers. So first thing I should do is simplify that, which would mean to factor out an x cubed term. If I factor out an x cubed, I got x cubed times 2 minus x. From here, it's easy to see that I have two critical numbers. The critical numbers are going to be 0 and 2. So now I can set up my test intervals. Okay? So now I need to pick a number over here in this interval, one in here, and one in here, and see if this is true or not. Well, an easy value to pick over here is -1. If I plug in -1 up here, I should see that I'm going to get -2 plus 1, and you should see that that's going to be true. Okay, because -1 cubed is -1, and then this is going to be 2 minus -1 is just going to give me 3. But that gives me -3, which is less than 0. So that's true. I satisfy on this interval over here. If I pick a number in between 0 and 2, let's say I pick 1, you should note that and here I'm going to get x cubed is equal to 1. 2 minus 1 is 1. So I get 1 in there. And 1 is certainly greater than 0. So I'm not going to be true in this region right there. And then I got to look at greater than 2. So I'll choose 3. If I choose 3 out there, I get 3 cubed, which is 80 is 27, times 2 minus 3. Yeah, it's going to give me a negative number. That's going to give me negative 27. And so there again, on this interval out here, I'm going to be true. That's going to hold. Now the difference between this one and the last one is that now my endpoints, I want to use those endpoints because at 0, if I plugged in 0, I will get 0 is less than or equal to 0. That's true. So the endpoints in this particular example are, we want those in our solution set, and there you can see our closed brackets like that. Okay? Here's some problems. Here's some examples to look at. Here's some problems at the end of the chapter to do. Again, if you have any questions, email me. But basically what we looked at tonight is we looked at making solving polynomial inequalities. We found the critical numbers. We set up our test intervals, and then we used those test intervals. We tested a point in each test interval to see when the inequality was true and when it was false. And then we were able to make conclusions about our solution set. Okay? Hopefully that makes sense. One more video to go, fellows, and then we'll be done with the week. Okay? Have a good day.